In this video, we will study the operating pressures of the refrigerant gas R600A in a domestic freezer, the equipment parts, and its operation. On the screen, we observe the refrigeration circuit of a domestic freezer that operates with the refrigerant gas R600A. The refrigerant R600A enters the evaporator in a liquid state at a pressure of negative 3.23 pounds per square inch. The negative sign means that the pressure of R600A within the evaporator is lower than the atmospheric pressure of the external environment. With this pressure, it is achieved that the R600A in the evaporator has a temperature of minus 18 degrees Celsius. With this low temperature, and the help of the fan, the heat from the food quickly passes to the refrigerant R600A, causing it to evaporate. As the refrigerant absorbs the heat from the food, they cool down, allowing for their preservation. The heat from the food passes to the refrigerant R600A in the evaporator, causing the refrigerant to progressively change from a liquid to a gaseous state. The R600A, now in a gaseous state, and with a slight temperature increase called superheating, is suctioned by the compressor. For this case, let's assume that the temperature of the refrigerant R600A in the gaseous state at the exit of the evaporator is minus 15 degrees Celsius. This means that the refrigerant R600A goes from minus 18 degrees Celsius to minus 15 degrees Celsius. Therefore, in this equipment, the superheating is 3 degrees Celsius. Although the temperature has a slight change, the same does not happen with the pressure, and we can approximate and say that the pressure of R600A at the exit of the evaporator is practically the same, that is, it still amounts to negative 3.23 pounds per square inch. The R600A, now in a vapor state, goes to the compressor through the suction pipe, which we can identify as the thickest pipe of the compressor. The pressure and temperature of the refrigerant R600A increase considerably in the compressor. The pressure of R600A at the exit of the compressor reaches a value close to 73 pounds per square inch. The temperature of 600A at the exit of the compressor can be around 60 degrees Celsius. In the condenser, the refrigerant must lose the heat absorbed from the food, and the energy absorbed in the compressor. This heat must be expelled in the condenser to the environment. This heat dissipation process is favored by the high pressure that the refrigerant R600A gained in the compressor. As the refrigerant R600A loses heat in the condenser, it changes from a gaseous state to a liquid state. The pressure of the refrigerant R600A in the condenser remains at 73 pounds per square inch, but the R600A significantly decreases its temperature. This decrease in temperature of R600A in the condenser allows the refrigerant to change from a vapor state to a liquid state. The R600A, now in a liquid state, and at a temperature close to the ambient one, exits the condenser and goes to the capillary tube to restart the cycle. In the capillary tube, the pressure and temperature of the refrigerant decrease significantly, so it returns to the initial pressure of negative 3.23 pounds per square inch and minus 18 degrees Celsius. The R600A, now in a liquid state, with low pressure and temperature, returns to the evaporator to start the refrigeration cycle again. On the screen, we are showing other pressure values usually used with R600A. As we can see, the working pressure values of R600A are notably low. Therefore, when recharging equipment with R600A, it is of special importance to work with a pressure gauge that can reliably measure such low pressure values. Additionally, it is recommended to carry out the R600A recharge process preferably by weight, with a suitable scale. The main drawback of R600A is its classification as a flammable refrigerant. However, since domestic refrigeration equipment does not have such high refrigeration capacities, and R600A has a significant cooling capacity, domestic appliances require very little R600A refrigerant, significantly reducing the risk. The R600A, being composed of only one gas, can be recharged or introduced into the equipment in both liquid and gaseous phases, making it indifferent. The R600A is compatible with any type of oil. However, it is recommended to follow the compressor manufacturer's recommendations. The main risk when performing corrective maintenance on equipment with R600A occurs when performing any welding. In this regard, it is recommended not to carry out this procedure without having previously completed a complete vacuum of the equipment with a vacuum pump, carrying out this process for several minutes, with the gas expelled outside. And paying special attention to possible accumulations of R600A in the capillary tube.